we need to determine the greatest value of W for which the rod remains in equilibrium. Okay, so I've redrawn what we've got, and obviously we need to forget now all of those answers from part A, because as soon as you change something, then everything changes in terms of the values of the forces. Obviously the distances aren't changing and we aren't moving W to a different place. So this idea about it being in equilibrium is to do with it tipping over. Okay, if you put a really heavy weight at W, okay, remember these are where it's resting, it's going to tip like that. Okay, RC, point C, is going to be the place where it tips around, and this point is going to basically not be needed anymore. This support is going to lift up. So what we want is how heavy can we place a weight at this end so it still remains basically horizontal. Okay, remember we've got this 180 pushing down in between the two supports, but that's not going to make it tip. Okay, but if you push outside where the supports are, then you could make it tip. So what we want to do is find what's going to make it just beyond the point of tipping. Okay, so then you can visualize it as it's balancing just on one support with the W here and the 180 here. So this support at D isn't needed. Okay, and then it turns into like a seesaw question. So if it tips, then C is the pivot and D is not needed. Okay, so what you need to imagine is that your situation is not even going to need RD in there. It's going to basically have this support at C, 180 there, and W there. That's your new situation. Okay, now we don't actually need to work out the reaction at C. Okay, we need to work out W. So we can do that by taking moments about C. Okay, that is the pivot point for our little seesaw. And all we need to say here then on this picture, if this is my pivot, pushing one way, the 180 is in charge. Pushing the other way, the W is pointing the way it's going. So we want the situation where they're balancing. So we can say 180 times 0.7 to tip it one way needs to be balanced by W times 1.2, which would try and tip it the other way. So it's actually a simpler calculation than part A, but you just need to think through what you should be doing. All we need to do is work out 180 times 0.7 divided by 1.2, and that gives me W is 105. So any bigger than that and it will tip up. That is the greatest value that you can put on there for it to remain in equilibrium. Okay, you can put less than that and it won't tip. You can put exactly 105 and it will literally just be balanced around point C, and you can take support D away and then any more and it will just tip.